Hey everyone, welcome to Code Harmony. Today we'll solve this question 3197 from LeetCode, which is find the minimum area to cover all ones part 2. This question is based on matrix and asked in Microsoft and Salesforce. The problem is marked as hard, but it is because it's a follow-up question to the one which we have already solved. That is 3195. Find the minimum area to cover all the ones in a grid. Let's say this is the grid and we have to find out what is the minimum area of the rectangle that we can draw so that we are covering every single one from the grid. Let's try to read the problem statement and see what is given to us. You are given a 2D binary array grid, okay? And you need to find 3 non-overlapping rectangles having non-zero area with horizontal and vertical sides, such that all the ones in grid lie inside these rectangles. So this is the operation that we have to perform on a grid, which is a 2D grid where all the items are either 0 or 1 and the grid size is around 30 cross 30 as max. The input is generated such that there is at least 3 ones in the grid. At least 3 ones means that it is possible to have 3 rectangles. Now what do we return? Minimum possible sum of area of these rectangles. So whatever these rectangles are going to be, just return the minimum possible sum. And rectangles are allowed to touch, but they are not allowed to overlap. Okay, so this is my problem statement, that I will be given a grid of binary items 0 or 1 and I have to draw some rectangles. In this case 3 rectangles, where those 3 rectangles are going to cover every single one from the grid. Let's say in this case, if I just draw one rectangle here, one rectangle here and one rectangle here, these are the 3 rectangles. And what is the area of these 3 rectangles? This rectangle has an area of 1, area of 1, area of 3. 1 plus 1 plus 3, that is 5. So 5 is going to be my answer. But to directly jump onto this problem, if in case you have not solved the previous one, part 1, then I recommend you go and watch this video or try to do it by your own and understand how we are solving this problem. And what is this problem? This problem says that you are given a grid 0, 1, 1, 0, 0, 1, 0, 1. This is the grid, and similar to the current question, this grid is a binary grid where all the items are either 0 or 1 and there is at least 1, 1. Now we have to return the minimum possible rectangle area so that we can cover all the ones, and we are allowed to use only one rectangle. In my current problem, it is saying that we need to find 3 non-overlapping rectangles. But if instead of 3, I just say that find one rectangle, then what will be that rectangle? That rectangle will be this much, right? Because if I consider the whole portion as a rectangle, the area will be larger, and we have to pick the minimum area rectangle. Minimum area rectangle where sides are vertical and horizontal. Okay, so what is this area? This area is 1, 2, 3, 4, 5, 6. 6 is the area. So in this case, the answer is 6. Okay. So let me give you a recap. My problem was that for this grid, just find 3 non-overlapping rectangles, and whatever is the rectangle of those 3 rectangles, minimum value is going to be my answer. So what I'm suggesting or what I'm taking as a prerequisite is that take the first part. First part, we are given a grid, binary grid. We have to get one rectangle where that area should be minimum as possible. So if you are unaware of this problem and you have not solved it yet, I suggest you go and watch this video. In this video, I have done it in a very simple manner, that if you are looking for a rectangle with horizontal and vertical lines, then check for the first vertical line where I am encountering 1, last vertical line where I am encountering 1, and first horizontal line where I am encountering 1, last horizontal line where I am encountering 1. It means that I am taking two variables, top, bottom, left, right, and I will be arranging in that manner that the left will be coming here. Left is the first column where I am encountering 1, and right is the last column where I am encountering 1. Because let's say if there is at least 1 0 0, then this is of no sense that we are taking this, considering this that column. Okay, so this is the range. This is the horizontal range from one vertical line to another vertical line where we are having ones. Now these are two lines. There might be the possibility that first row is having all the zeros, last row is having all the zeros. So we need two horizontal lines as well. So for those two horizontal lines, I'm taking top line and bottom line. So top line will be pointing to this one, first row, and bottom line will be pointing to this row in this example. So these four corners are going to make me one rectangle, and my work is done for this problem. But my current problem is saying that you are allowed to take 3 rectangles. If I am allowed to take 3 rectangles, so how do I proceed it further? See, at least I should perform this step, that from the grid I am able to get one grid with the minimum area. And now in this grid I will try to have subsection further. So from one grid I will try to go to 3 number of rectangles. But in between, let's explore how we can get 2 rectangles. Now in the given shortest rectangle, how I can divide this rectangle into 2 rectangles? There is only one way I can see, either drawing a horizontal line or drawing a vertical line, right? Let's say vertical columns are column number 1, column number 2, column number 3. 3 columns are there. Row number 0, row number 1, row number 2. Or there were 2 rows. Let's just take 2 rows. Okay, 2 rows and 3 columns are part of this subgrid. And in the subgrid, we have only one rectangle. Now let's try to explore further and have 2 rectangles. So what are the different ways? I can either have a split like this, either have a split like this, or I can split like this. Apart from these 3 splits, I don't have any other way. So whatever combination is giving me the right answer, just take that. But every case is going to give me the right answer, correct? Same answer, right? If I'm drawing something like this, it's the same rectangle. If I'm drawing something like this, sum of these 2 rectangles. If I'm drawing a horizontal line, sum of these 2 rectangles. It will give me the same result, right? But ultimately we have to get 3 sections, right? So when I am making one cut, I am having 2 rectangles from one rectangle. Now for one portion, I can further make a cut, and that portion will make 2 rectangles, right? So initially this was the case. When I made from 1 to 2 rectangles, it became 2 rectangles. And now to make it 3, either this portion can have one cut or this portion can have one cut, correct? Either this portion cannot have one cut, or can this portion have one cut, right? This is something we have to do, correct? So what is my problem statement? That let's say DFS function, or maybe let's say solution function, we are writing left top is, what is the left top pointers? Top, bottom, this is top, this is bottom, this is left, this is right. Top comma left is the leftmost portion, right? And bottom and right, this is the rightmost corner. So these two values are specifying the whole grid, and to this grid I want to have 3 sections. I want 3 sections from this grid, and whatever is the sum, just return that. So this is our problem statement. So firstly what I did is I just reduced it to a single valid grid that I can take. Then I will try to further reduce it to 2 and then further to 3. So this is equal to considering one split. Let's say one split is this one or this one or this one. Let's say if it is this one. So first column 1, 2, 3, 4, 5, 6. First column is a part of the first row. So it is equal to solution of 0, 0 to 1, 0. So these are the coordinates of left top and right bottom of first section, and this is my first section. What is the second section? Second section is left top corner is 0, 1 and right bottom corner is 1, 2. In case if not 2, I will keep these coordinates as 0, 1, 2. Then it will not make any disturbance. Okay, so you don't need to validate these indices. You need to understand what the logic behind it, because this is not a very good problem to solve, but we have to solve it. So this is one portion and this is second portion. So what I can say, that for one portion, for first portion, just try to make one rectangle out of it, plus for second portion, which is going from 0 to 1 and 1 to 2, try to get 2 portion out of it. So my current problem is now reduced to 2 sub problems. Set from the whole grid, try to get 3 rectangles. Then from this portion, try to get 1 rectangle. From this portion, try to get 2 rectangles. Now from any portion, when we have to get 1 rectangle, this is the same problem that we solved yesterday in this 3195, right? And what about the second case? Second case is something like try to make a line, right? Try to make a line. When in this problem I made a line, I got 2 problems. One portion, there is nothing to do with that, just 1 rectangle we have to get, and from the other portion we can get 2 rectangles, and for 2 rectangles we are clear that we have to just make one split. So this is how we can reduce our problem to subproblems, subproblem 1 and subproblem 2. If I just pick the same example again, let's take this example 1, 0, 1, 1, 1, 1. So 1, 0, 1, 1, 1, 1. So in this case 0, 1, 0, 1, 2. Solution from 0, 0, left top to right bottom. Right bottom is 1, 2. What I need to get is I need to have 3 portion. I need to have 3 portion out of it. Okay, if we have to get 3 portions, first of all, what I can do is I can do some kind of pruning, like if there is unnecessary row or column or bottom column, last row, then we can avoid those. But in this case, I don't think there are some such cases. So this is my problem. And here what I have to do is I have to make some cuts. If I make a cut, I will have 2 rectangles. So 1 rectangle can go and further have 2 rectangles. So ultimately you will get 3 rectangles. So let's say I made this cut. If I made this cut, it will be something like this. Solution of left top coordinates is 0, 0. Right bottom coordinates are 0, 1. And from this portion, let's say 1 rectangle. And ultimately this problem is going to return the sum. What is the second problem? 0, 1, 2, 1, 2. And from this section make 2 cuts. So this is one rectangle, and here in this case, if it is one rectangle, I need to find out, I can shrink it as less as possible. So the least value I'll get is 2. So it will give me 2. And for this portion is something like this bigger portion. Okay, and this bigger portion I will also try to make a cut. Let's say I made a cut at this position. So what are the two sub problems I will get? Solution of 0, 1 and 1, 1. From this portion, just get one rectangle. And what is the second portion? Solution of 0, 2 and 2, 1, 2. 0, 2 and 1, 2. And from this portion also, try to get one rectangle. Okay. And this portion, when I will try to get one rectangle, I will try to shrink it. See, one rectangle I need to get. If I have to get one rectangle, and the grid is something like this. Grid is like this. This is the grid. And to shrink it further, this is the left cut, this is the right cut, this is the right top cut, and this is the bottom cut. So top cut is ignoring this portion, and we will get 1 out of it. And this portion is having grid something like this. So cuts are like this. So 2 is the area from this. So 2 plus 1, 3 is the area from this, and 2 is the area from the left part, and ultimately this value is going to give me 5. So this is something we have to do. And ultimately we had to return the minimum possible sum of all the rectangles. So if the rectangles we have to make it 3, so after making one cut we'll get 2 rectangles, and from those 2 rectangles, let's say left portion or first portion is going to give me 1 rectangle, and the later portion is going to give me 2 rectangles, and subsequently making a subcall will give me the answer. And what is my base case? Base case is like when we have one rectangle, we'll just have to make a shrink. It means when we have to make one rectangle, the problem is this one, the previous one. This is something we have to do. So in the interviews, let's say if they are asking this problem, and if we are able to solve this problem comfortably, they might ask us this problem as a follow-up question, and still they can further ask us the follow-up question like how we can, if we are making subcalls, do we have overlapping subcalls? If we have overlapping subcalls, how we are going to memorize them? So this is something we can expect in the interview. Okay, so this was all about the problem explanation, how we are going to solve this problem. I didn't like this problem much, so I'm just directly going to show you the code, and I will attach it in the description below. You try to understand it by your own, and still if you face any doubt, you try to do the dry run, and this is the approach that is not so difficult to understand. Let's have a look on the code here. First of all, this is our main function, minimum sum. We are given a grid, and on this grid we have to get the minimum sum by making 3 cuts, 3 rectangles. So when we are making a cut, we can either cut it horizontally or vertically. So applying our brute force, like making cut horizontally or vertically and then solving it recursively, is going to give us TLE, because over these many cases, 30 cross 30, it is going to have a lot of sub problems, and it is going to give TLE, and that will be too slow. So if I have the grid and if I am rotating that grid, it means every time we are making similar type of cuts. So if I am writing my code on making horizontal cuts, if I rotate the grid, that is also horizontal cut. So for that case, we have utilized this formula, given grid and rotated given grid. So now we can either only have horizontal cuts. So when we are having horizontal cut, we have 2 cases. When we are making horizontal cut to a grid, so let's say if I made a cut from a grid. Let me show you. If in case this is the grid, right, then when I'm making horizontal cut, okay, this cut I have made, and now I have 2 possibilities. Either I make one more horizontal cut, then I have 3 rectangles, or I can have this cut, then I will have 3 rectangles, or I can have this cut, then I will have 3 rectangles. So this is something which is implemented in the code. So whatever is the grid, first case is the L-shaped patterns. Let's say that we made a horizontal cut, and on the upper side we made two rectangles, and on the lower side we made two rectangles. So top left, so top rectangle, bottom left and bottom right. So in this case we are keeping two section under the horizontal cut, and in this case we are keeping two section above the horizontal cut, top left, top right and bottom section. Otherwise, if we are not making cross diagonals, then we are making two horizontal cut. If we are making two horizontal cut, we are getting three rectangles. So that is another case. And after that, so whatever is the case, whatever is the rectangle we are having, to shrink that rectangle, we have the same logic. And what is that logic? Whatever is the rectangle, take the first one from the left side, last one in any column from the right side, and first one from any column or any row from the upside and downside. So that is the same logic, which is like previous question, find the minimum area to cover all the ones with one rectangle. So this is the main portion, that's solving it using these three approaches. Either one horizontal cut, and after making one horizontal cut we have two sections on the upper side, or maybe two sections on the lower side, or just make two horizontal cuts. So that is the code. This code is also having all the valid comments. You can read out all the comments and try to understand the logic and the intuition behind the problem. I've already solved in the description. Okay, thank you guys, thanks for watching. I hope you have understood a bit from this problem statement. Thank you for watching again. Bye guys. In case you get any doubt, do let me know in the comment section below.